Okay, welcome everybody. Welcome to the Construct Innovate webinar series on sustainability planning and construction that we're hosting together with Engineers Ireland West Region. My name is Jamie Goggins and I'm Director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. So this week, which is our last week in the webinar series, we're going to focus on heritage, culture, communities and sustainability. We're delighted to have three fantastic speakers today. We have John Burgess, who's an Associate Director of ARUP, and he's going to talk about the adoption of passive and low energy control solutions for managing museums, art galleries, and archive storage environment. Then we have Peter Cox, who's Director of Carrig Conservation, and he's going to talk about how can older buildings contribute to reducing CO2 emissions. And then we have Conor who's CEO of the Port of Galway, and he's going to talk about sustainability and the Port of Galway. So we'll go through the first three presentations. Each will last about 15 minutes or so, and then we'll go into the Q&A session. So if anybody has any questions for any of our speakers, please post them into the Q&A function at the bottom of the screen, and we'll deal with all the questions afterwards in there. So without further ado, I'm going to hand over to our first speaker. First speaker is John Burgess, Associate Director of ARUP. I'm going to talk about adoption of passive and low energy control solutions for managing museums and other buildings. So over to you, John.
Good afternoon, everyone. Sorry, my name is John Burgess. I've just come hot off the press from a weekend in Birr, where we had our first Engineering Heritage Festival, celebrating the rich heritage of engineering and science that Ireland had in the 1800s, that carried through into the 1900s. Today, I'm going to speak to you about the gallery environment, and to align with culture and heritage. And it's apt because at the moment I'm involved in several projects where we're looking at renovating existing art galleries. The one of note at the moment is the Crawford Art Gallery in Cork. Today, following a brief introduction, we're going to have a short recap of industry standards, look at one of the elements of the Energy Performance and Buildings Directive recast, and discuss some of my project experience. And just due to time, I am going to skip through these slides pretty quickly. They will be available for you to read afterwards, so don't try and read the text. Key issue for galleries, museums, libraries, and archival storage is how to do it in the most energy efficient way. We are plagued with overzealous standards that says, well, you must achieve 21% plus or minus half a degree at 50% plus or minus 0% RH, which will lead to, crazy amounts of energy consumption. Now, we do get a small leniency on the RH, and we have plus or minus 5%. But that in itself is not enough. Just looking at the industry standards, BS 5454 and BSCN 16893, we see that there is a realization, a dawning really, in these standards to allow engineers and curators to work together to make the best use of the fabric of the building and to understand what is the real requirement for the curatorial storage environment. The main thing is to avoid sharp fluctuations in temperature and humidity. And guess what? The thing that's most likely to cause a sharp change in temperature and humidity is the operation of the HVAC systems, the heating, ventilation, air conditioning systems themselves. So one has to be very careful in over-designing and picking equipment that's sized and designed for the peak winter or summer condition or the peak internal loads, when most of the time that never eventuates. Looking at BS 16893, key focus there on sustainability. And they're saying there straight up, can the collections be protected through passive or low energy means? And interestingly, on the Crawford Art Gallery, I'll speak about two examples of that shortly, where certainly in my career, I've had to change from what I originally would have started out putting in a boiler and a chiller system to achieve not only heating and cooling, but dehumidification. to one where maybe we could disband with them altogether. Building acclimatization is another key factor, that new buildings take a little bit of time, at least 6 months, if not a couple of years, to completely dry out, particularly if you're using a concrete structures. Thermal inertia, we all know that the heavier the mass of the building, the more stable the temperature control will be. The same can be said for moisture, that provided we maintain connectivity and allow moisture to flow through the fabric, we are able to avail of a similar inertial gain for control of RH. That last point at the bottom of that slide, infiltration. Key to success, you cannot maintain a closed controlled environment if you have a leaky building. And the air infiltration tests need to achieve less than half a meter cube per square meter per hour at 50 pascals, which is 10 times less than that set by TGD Part L. And air conditioning for storage repositories need to be able to be switched off. I mean, the loads in a storage repository are typically zero. There's no people in there, there's no lights, there's minimal ventilation. So it's not expected that the air conditioning systems need to run all the time. And when they do turn on, they need to be able to turn on and deliver part load conditions. The National Museum of Directors Council and the BISOT Group Green Protocol have further increased the flexibility. And they're saying that the range of relative humidity can vary between 40 and 60%, but not in any one day, maximum of a 10% variation in any 24-hour period. And the range in temperature can float between 16 and 25, again, with very, very small fluctuations in any one day. Anything that requires really close control should be displayed in sealed cases. So the Energy Performance and Buildings Directive was recast for its second time under the work of Kieran Clough here as the rapporteur for the committee on industry, research and energy. But it's just interesting to note that Pat Cox, who was the president for the European Parliament in 2002, introduced the EPBD 22 years ago. Doesn't feel like 22 years ago to me. And I'm sure most of the people on the call will know of Kevin O'Rourke, who helped implement the building energy rating protocols in Ireland, which are probably one of the most highly respected building energy rating schemes in Europe. Just to note, in 2018, the EPBD was amended to put emphasis on building automation and control systems, and that found its way into TGD Part L already. The long-term renovation strategy, now incumbent on all public bodies to achieve a 3% of their property portfolio renovated every year, moving from a low BER to a nearly zero energy building, and eventually by 2050, a zero emissions building. We see in the new EPBD a focus on embodied carbon and whole life cycle greenhouse warming potential of buildings. So as the operational part of our buildings, the associated carbon drops, we need to focus on retention of existing buildings as opposed to building new ones. Peter will speak about that shortly. So in the TGD Part L, and this has been in play for a few years, our BMS systems, our building automation control systems, need to continuously monitor, log, analyze, and allow for adjusting energy use. I've yet to come across a building that does that. And we do have building management systems, but are they actually being set up to continually log and analyze? Are they benchmarking the building's energy efficiency to detect losses or drift and reporting back to the building management? Again, very few cases where that is happening. That needs to change. Just as an example, here is a graphic of a typical air handling unit for a building management system. I expect most people will be familiar with that. And it tells you quite a lot when you're looking at the screen at that point in time. What is it doing now? But what it doesn't tell you is what did it do this morning? what did it do yesterday on Bank Holiday Monday? How is the building performing? And capture of that data, typically in a cloud-based archive, to allow data analytics platforms to present back in graphical form for any period of time over the past several years is what is needed. And that is really what's needed for keeping an eye on what's happening in the gallery. Some project experience, just looking at the Crawford Art Gallery here, which is about to undergo a serious renovation. It's being decanted of its artwork as we speak. I worked on this building 24 years ago when Eric van Egeret, an architect from the Netherlands, designed a wedge-shaped infill. And there were 2 floors, and the 2 floors of that gallery were going to be the close control environment. In went a large air handling unit, in went the boiler plant and the chiller plant. And in the first month, the manager for the building, Ray McCarthy, called me and said, "John, how did I end up with a €10,000 bill for the first month?" Went over to have a look, and no, the RH didn't have a deadband. So that was easy fixed. And we gave the curators the choice to shift the deadband from plus or minus 5% to plus or minus 20%, depending on what was showing or what was it a vacant period in the program. Now for the renovation, we've looked further and we've reduced all external influence, solar gain, temperature loss through the fabric on the Van Egeret Gallery, taking account, though, of the people that are still expected to travel through it. And we've reduced the incoming fresh air requirement, we've reduced the ventilation rates, and really made considerable reductions in the energy use for the building. Following that, the Luxembourg Art Gallery, where we looked at using geothermal heat pumps coupled with displacement ventilation systems, where the lowest cooling temperature was 19 degrees and the highest heating temperature was 29 degrees. And these much lower operating temperatures than you would typically see in a conventional system have led to a massive decrease in energy use. Looking at the conventional system, we were looking at 1.7 gigawatt hours of gas. That was reduced to just shy of 180 megawatt hours. Electricity use went up because we were using heat pumps. So increased from 60 megawatt hours to 190. But the carbon reduction each year, we saved approximately 250 tons of carbon by adopting renewable energy technologies. I was visiting Cambridge last year and I went into the FITS my first time. A very impressive gallery. All the gallery spaces are of good proportion and really nice, but I couldn't help getting over a lot of rooms had noisy HVAC systems running full bore, and I would predict that building was consuming a lot of energy, paying a lot on their bills, and not achieving stable control, reassured by the noise of the air conditioning in the background. This is an example now of a passive, using the passive elements of the building, the Jersey Archive. This was undertaken by my colleagues Mike Holmes and Chris Twin. And really they pushed the boundaries here to look at reducing the ventilation rates. Typically we would ask a building services engineer what should be the air change rate, 1 to 2. But actually for the Jersey Archive, being a storage, it's 1/20th, 0.05 air changes per hour. I had to scratch my head when I looked at that. That then looked at using the concrete mass fully exposed to the internal space, sealed with a vapor permeable barrier, externally insulated, protected from the sun, and achieved so much in terms of providing a passive control without any introduction of HVAC systems. This was another project I visited in the research for the Crawford Art Gallery. This is the Lambeth Palace Archives in London. And here they had 9 archive rooms, all served by one, duty standby air handling plant on a shared rota. So the rooms did not need full 24-hour temperature control from the HVAC systems. Again, relying on exposed concrete structure for maintaining the internal environment. So just wrapping up, some design considerations, apart from what I've just said. Low energy lighting, obviously, low occupancy levels. And one's got to be careful that you don't mix up an archival storage area with that of a gallery where people are passing through. Remember about latent gain from people, particularly in wet weather. Try and have a cloak room. Encourage people to take their coats and leave their brollies outside the gallery spaces. Low velocity air movements, displacement ventilation, as I mentioned earlier, and control the movement of people. Don't just let them all flow through when they arrive. If there are already 20 people in a room that's designed for 20, put a hold on it, retard the movement of people. And then in moving in, allow time for the building structures to dry. If you're using a wet washdown, remove moisture with toweling. Do not use hot air dryers. And then monitor the temperature, humidity, and indoor air quality using an archival system coupled with the building management system to prove how the building is working and learn from its shape, its design, and the systems that are operating in there. Avoid oversizing of HVAC equipment. So much is unnecessarily spent for buildings that don't need it. Minimize fresh air intake, so indoor air quality sensors. Use a waste heat from heat pumps in cooling mode to reheat cold air. Use the wider bands suggested by the Bizot group. And use moisture permeable paints on the internal surfaces. So, yeah, that's it from me, I think. Yeah.
Brilliant, John. Thanks a million. Okay, so that's a good presentation on the storage areas within galleries and what we can do to minimize energy consumption while also meeting the performance requirements within there. If you have any questions for John, then please put them in the Q&A at the bottom of the screen. So next up, we have Peter Cox, Director from Carrig Conservation, who's going to talk about can older buildings contribute to reducing CO2 emissions. So over to you, John, or over to you, Peter, sorry.
Yeah, I'm here to defend older buildings, and but also to highlight some of the things that John was saying, that we certainly need more kind of hard evidence and recording of information when we do a proper retrofit to an older building. Next slide. I'm just going to go through an introduction, one simple message, and then kind of that we as an industry really do have to do something, because we do need to reduce our carbon emissions. Next slide. Carrig, basically, I actually, my undergrad is chemical engineer, and then I got into building physics and building material science. So that's my background. We specialize in conservation, but we've also written the recent kind of energy efficiency guidelines for the Irish government and also for historic England. And we offer a full kind of conservation, architectural and energy retrofit kind of package. And then we have a research wing where we do a lot of research in climate change and climate change effect on heritage, etc. And more recently, we've gotten more involved in training, because training really is important. Next slide, Jane. Sorry, and if you hit the next button, what do these buildings have in common? Next slide. And next slide. They're all gone. And this is one of our biggest bugbearers of, we do not calculate in any of our systems the actual embodied carbon. And John kind of did reference that in the new EPD we are finally beginning to recognize this. Next slide. So what's the issue? next slide. It's embodied carbon, next, and whole life cycle assessment. Again, John touched on this. Up till now, we've really only been concentrating on operational energy. So when, I pass a brand new building going up on Harcourt Street here in Dublin, where they've just demolished the old Garda headquarters, which was a massive building. And then they're building a brand new building of concrete, steel, and glass. And yet, on all the hoarding, they have this is a zero energy building. It's a zero operational energy building, perhaps, but if you take all the embodied or embedded carbon that's gone into dumping the old building and then renewing it with the highest carbon intensive products such as concrete, steel, and glass, then it's not true. Next slide. 12.7% of our, and this is back in 2017, the built environment total gas emissions was 12.7. Next. Global emissions for the construction industry, 34% of global energy demand, 37% of energy and process related emissions. And that's of 2021. And sadly, they are still rising. Now, yes, Ireland is coming down a bit. So we really do need to get into whole life cycle assessment and how do we evaluate that? Next, and whereas we used to talk about cradle to grave, next, Jamie, we really now need to talk about cradle to cradle, because when we're demolishing a building, you can't just dump it. And no matter who tells me that they're recycling 70% of a demolished building, I do not believe. They might be downcycling, like using it for roads or something. Now, it does have some value, but we really do need to get a handle on this. Next slide. So what is life cycle assessment? It's taking the raw materials, the progressive kind of manufacture, the transport, the construction. What I didn't add in there, and I should do, and I will for my next presentation, is packaging. There's so much waste in packaging. And then you've got the operational heating, cooling, ventilation. And as John was saying, we can really reduce this if we take a real life cycle assessment analysis on buildings of what they actually need for the purpose of the building. And then, of course, you've got maintenance, and particularly in dwellings where people are putting in UPVC double glazing, they don't take into consideration that they only have a life cycle of about 15 to 20 years. In a lot of cases, the gas-filled double glazing loses its gasket within 10 to 15 years. So that has to be either replaced or it's non-functional. And then, of course, when we're retrofitting, we don't want to be using carbon-intensive products such as, say, polystyrene or polyurethane insulations for two reasons. One, they're very high carbon to produce. They're impossible to recycle. And two, they are a closed pore type of material, and therefore it's not doing the building any good whatsoever. And then, of course, end of life, demolition, transport, recycling, landfill, and that's all coming down. Next slide. So very simply, and again, as John said, you can read these much better when you get copies of the slide, but the sum of all materials embodied emissions really goes into the building, and emissions within a research study period. Next slide. And again, we've got to really start calculating what are we doing to demolish buildings? What are we losing? What are we costing? The other thing, I keep hearing all the political parties saying that we need to build 50,000 new houses every year. If we do that the way we build at the moment, we're not going to meet any targets whatsoever. Next slide. And then the demolition, you've got to look at the construction and demolition recovery rates, emissions, and landfill, and then what do we do with those landfills later on? So if this modest building and this was part of a study for Historic England, is demolished, how many years does it take to pay back the carbon? Next. And next. It takes 63 years, even by designing a brand new building that is operational energy neutral. It'll take 63 years to pay back. Next slide. So what would a building like this take? Next. Probably about 500 years. Now, don't get worried, we're not going to demolish this wonderful building in Dublin. Next slide. So what's the answer? Next. We've got to stop and think about demolishing perfectly good buildings. And again, hitting on something John said, I think kind of standards and building directives and building regulations really need to be aligned more, because they're not at the moment. So to me, you must understand your building. What are you working with? What do you want to achieve? Do a detailed analysis on the building. Take a holistic approach to adaptive reuse. And then use renewable energy, PV, wind, geothermal, and employ low carbon solutions. Next. These are a few projects that we've been involved in. This is Park Hill in Sheffield, which was a 1953 concrete. Next, and it kind of got nicknamed the Spider, but it housed 1,100 families up till about the mid-1980s, when a lot of social unrest became, and they emptied this building. We got involved in about 2002-03 with Sheffield City Council, but also with a very exciting developer called Urban Splash, who came in to try and save the building. And we've finished phase 1 of it, and we're about to start on phase 2, which is really phenomenal, saving of carbon by reusing and modifying and energy upgrading this massive complex. Next slide. This is the Rubrics building in Trinity, and again, going back to John, we were lucky that Trinity College allowed us put in a really super BMS building management system in here. But that red brick facade, when we have invested in actual U-value testing gear. And so we went out to this building when we got appointed as conservation and energy consultants to the team. And we did a real live U-value test on this red brick building, which is about 540 millimeters thick. And we didn't believe it when we got the first reading, and we did it twice again. And this wall actually gave us a U-value reading of 0.83. So we did not need to use insulation on the inside of this facade. So by understanding what you're doing, whereas, and I appreciate Kevin O'Rourke's BER system, it was designed for post-1970s buildings, not for older buildings. And if we were to do a BER on this, we'd have to give it a default of 2.2 U value. And therefore we'd be trying to put 200 mil insulation on the damn thing. And if we did that, then we'd be overheating everything, and we'd be A, costing a huge amount of money, but B, destroying the fabric. So it really is important not only to know how to go about renovating and particularly energy upgrading older buildings using more natural materials. And then obviously recording and having hard evidence that will lead to reduction in cost and more knowledge. Next slide. We've also been lucky, and we have an office in London, and we did both the Tate Modern, which is the building behind with the chimney, and then Tate 2, that was a really odd shaped building. We did all the material and fabric analysis on that. Next. Battersea Power Station I've been working on since 1998, would you believe? And it opened in 2022. But again, it's a phenomenal building that has been saved and renovated and in fact, energy upgraded. We weren't involved in the energy side on this, but it was Borough Hatfield were the engineers on this. Next slide. This is a derelict church in Dublin that the man on the scaffold is Derek Tynan, architect, and I'm sure he's saying to himself, what the hell have I got myself into here? But next slide. And this is it today, and it's actually won both of us, Derek and myself, many awards for its performance, but also for its and what we discovered, there was a full crypt underneath, so we couldn't put 3 loading floor loadings on the crypt. So you'll see the fancy trusses that we designed for the roof, and Cora engineers helped us on this one, and we hang the 2 upper floors off the roof, which is settled on the original walls of the church. And it's now the Dublin headquarters of J.J. Rattigan. Next slide. So there really is a great need for training and education, and I think this is where all our institutions need to come together and really start doing this and to increase the education on all levels within sectors. Next slide. That's me. Thank you. Next. Thank you very much.
Great. Thank you very much, Peter, and great examples there of different projects and showcasing why we want to conserve buildings and how they can be conserved in there from, I suppose, the monitoring side from in Trinity College in Dublin, and proving that you don't need to do major interventions that on paper might suggest, to the church, the converted church, where it's obviously a major upgrade, but still being sympathetic to the original building and that. So we'll move on to our next speaker.
Sorry, Jamie, I forgot to add, the church we got to B3, and the rubrics building we got to B2 energy rating, which is pretty phenomenal.
Good, very impressive. Okay, so if anyone's any questions for Peter, then put them into the Q&A function at the bottom of the screen, and we'll pick them up at the very end. So I'm moving over to our third speaker. Third speaker is Conor Dowd, CEO from Galway Port, and he's going to talk about sustainability in Port Galway. So over to you, Conor.
Thanks, Jamie. Can you hear me okay?
Yep.
Yep, great. So Jamie, thanks for the invite. I very much enjoyed the previous 2 presentations. I hope I won't keep you too long before your lunch, but I suppose what I'm going to talk about today is just some background to the port in terms of our general operations, and then talk about 2 major projects and hope to demonstrate how they contribute to sustainability goals, both in terms of renewable energy, and demonstrate the key role that ports such as our own play in the energy transition, and also then in terms of urban growth, and hopefully in the future that we'll enable sustainable travel, tourism in the city centre, etc. So what do the Port of Galway do today? We're an important port for the city of Galway and the wider region, but we're quite small in truth. And our principal we're a bulk port, and that's important. Other than the operation of a ferry service to the Aran Islands, we don't deal in passengers, and we don't currently deal in containers. So it's largely bulk imports and exports, and oil has been traditionally a very strong import fuel, now thankfully less in importance, and basically usurped by other cargoes in recent years, particularly wind turbines, which I'll speak to in due course. And then, interestingly enough, some of our exports, and those of you from Galway will notice the scrap steel on the pier. It's actually very full at the moment, ready for export. But that's a classic example of the circular economy in action, with scrap steel being exported for the Port of Galway to be made into steel, typically in Spain, and refuse fuel, which is exported from the region for use as a heating product, typically in the Nordic regions. Briefly talk about the proposed port relocation and extension. It's a very long-running planning application for the new port, and you'll see there the existing port on the top left of the screen. And even in that visual, I think it's clearly seen how it's very small, and it's not particularly suitable for a modern port and to provide better services to our customers. We're only open 4 hours a day. We're very restricted in the size of vessel we can take. So it's our proposal to relocate to a new port facility there, which will be open on a 24-hour basis and be able to take far larger vessels and provide better value for our customers here in the west of Ireland. Couple of points I should make there, which are relevant to today's agenda in terms of sustainability. So at the moment, we're limited to vessel sizes of about 5,000 tonnes. Were one to relocate to the new port, we'd be able to handle 20,000 tonne vessels. And the critical point there is that that would mean one vessel instead of 4. So we'd have less vessels at the port, but critically, it means less voyages for the ships, less emissions. So, a bigger port will significantly reduce emissions in terms of the vessels calling at the port, which is an important message. And I'll talk to onshore wind later. Another key point is that if we relocate the port, one enables an urban regeneration project at the Port of Galway. And that's illustrated on the diagram there. And the key point, it's 2 phases. So phase 1 is near term and phase 2 is more longer term. And what I mean by that is phase 1, we're working at the moment with our colleagues in the Land Development Agency. And that will enable, it's predominantly housing in nature, and that can be built on in reasonably short order because it doesn't impact on port operations. The remaining land bank will only be enabled in the event of port relocation. And I think the key point in terms of sustainability here, I'll talk to the public realm benefits in a moment, but there's very little parking provision planned in terms of this urban regeneration project. And that's predominantly because the urban regeneration site is right in the heart of the city, and just to the top of phase 1 there, that's Cairn Station. So it's a superb location in terms of facilitating public travel to the residents in the new urban quarter and those visiting it as well, to work or enjoy the quayside cultural activities and the bars and restaurants that'll be seated therein. So it's a perfect example of reorienting and developing an urban brownfield site right in the heart of the city, rather than building up the city in the suburbs, which is entirely consistent with the goals of the National Development Plan. Just to point to some public realm here, which is critical. I won't touch through it all, but in many ways, the key would be the key areas. So the old working quays would be basically given back to public realm. And those of you who might have enjoyed Seafest or the Galway, the Ocean Race would remember those spaces being opened up to the public. So effectively, what you're doing is you're enabling the quayside to be brought to the benefit of public and visitors to the city. And we've also some new green spaces and a loop trail about the Lochatolia Inlet as well, which would provide effectively an alternative walking passageway for people to enjoy in the heart of Galway City. Critically as well, I'm not going to dwell too long on this, but it's a really important point, is that in line with national, regional and local policy, it's all about getting people involved in active travel. And what I'm trying to illustrate by this slide is how a number of the proposed walking and cycling routes could come through the port. So effectively, you keep that coastal aspect to the walking and cycling trails. So in the event of the port being relocated and the urban regeneration project proceeding as we intend, we could open up the port lands to facilitate the walking and cycling trails to come through the port lands. You know, with that urban regeneration aside, it allow people to park up their bike at the port, at the new urban regeneration site, walk down the town using the quayside, and it really does provide a great, I think, focal point for the west to east and east to west cycling and walking trails to meet, converge at the port, allow the individual then to spill down into the city centre, but without need for a car to access the city. So it's something we're very excited about, and have indicated our willingness to engage with the city and other agencies to try and make that happen over the coming years. In terms of the vision for the Inner Docks Land Regeneration Project, if one wants to learn more about it, I'd refer you to www.galway-harbour.com. We did conduct a non-statutory consultation on the project back in May 2021, and I'm pleased to say it was well received by stakeholders in the wider general public. It's also been referenced in the Galway City Development Plan. I mentioned of our work with the Land Development Agency, and an important further one just to mention in passing is EIB, the European Investment Bank, have an advisory agency called Jaspers, who provide advice to us free of charge, which we greatly value, which brings us into line in terms of the best urban thinking about, you know, issues such as sustainability, public realm, etc. So something we very much value, and it's great to have those on board as an advisory partner. So that's the urban regeneration project, which I suppose is sustainability for the citizen here in Galway in terms of providing active travel and public realm and living and working beside public transport links. But I think what also is key, that ports are to the forefront of the transition in terms of renewable energy. And our port is extraordinarily proud of the role we've played in onshore wind, and just calling out the numbers there, but approximately 800 megawatts since we started this activity in 2014. Now that's an enormous contribution. You know, we're a small port when it comes to tonnage in an Irish context. We'd be less than 1% of tonnage. But when it comes to deployment of renewable energy, we're trending 16% when I last looked, but that'll have grown because we've been very, very busy in 2022 to 2024. And we think there's a very strong outlook in terms of onshore wind. I'll come to offshore in a moment. And then over future years, you're into repowering as well, which is when the older wind parks will be taken down and replaced by newer wind parks. So it's been the important point for today is that this cannot happen without ports. So, you know, you cannot facilitate the energy transition without ports, and it's a role we're really proud of. When it comes to future years, I think there's the key resource we have off the west coast of Ireland. We've got the best wind speeds in Europe, and that opens up all kinds of different activities. When you look at the amount of wind that there is off our coast, I mean, the much missed Eddie O'Connor talk 70 gigawatts. The programme for government is actually, I should have updated that, it's now gone to 38. But however you look at it, there's a vast amount of gigawatts latent off the Irish coast. I think what will happen, it will come east coast, south coast to west coast. The various income streams will be, you know, there'll be all kinds of activities that are required for this, and all different types and sizes of Irish ports will have an important role to play. Some other interesting things which are in a period, and it's hard to know how they will evolve, will be hydrogen. We have a huge opportunity in Ireland to turn wind into hydrogen, have that exported to the continent, or indeed used in the hydrogen economy here in Ireland. And the other thing which is deeply interesting and will happen over time, the fixed fee floating. So fixed technology would be for the Irish Sea and maybe the southeast coast, and you move towards the wilder waters of the Atlantic off our coast, you're likely to be in floating technology, which is probably at an early stage in terms of deployment around the world, but could and will be commercial, and that represents the giant opportunity for the Irish West Coast, and indeed then for ports such as ourselves to play a key role in enabling that transition. Before wrapping up, just to mention a couple of things. We're very active in terms of engaging with the wind energy industry. We're active members of Wind Energy Ireland and Wind Europe. We're also acutely conscious of, in addition to supporting the role of the import and deployment of wind turbines through the port, be they onshore or offshore, there's also, I think, and it's probably not as well understood, there's a huge amount of white collar work in the renewable energy industry. We're very keen to support the startups and scaling industries, work with third level. Again, because our city centre location, we think and the Marine Institute is in Galway, the Ryan Institute, some top class people working in the universities in Galway, partnering with them to maybe facilitate a renewable energy campus where you bring together the best and brightest minds in third level and in our startup community, have them sited at the port and contributing to the energy revolution. And we're also working with a range of partners, including the University of Galway, for a multimodal hydrogen hub based at the port, which would supply hydrogen for local use. And that would be predominantly for, in the near term, for certain industrial uses, but more so for bus travel, which is we see hydrogen is more likely to be used rather than for cars. And I suppose the other thing we do all the time is we're constantly alive to opportunities in the renewable energy sector, talk to the developers, the survey vessel providers, engaging with government. You know, how can we work with government and the various regulatory agencies to expand our ports, enable the port project of which I spoke, so that we can do even more as a port community to contribute to the Irish renewable energy. So I suppose the key message for me today is the absolute critical role that ports have to play in the energy transition, the role we are playing as of today, particularly in onshore wind, but as offshore wind develops, we can do more and we will do more. And with the support of government, we stand ready to play that role, both in the near term, medium term, and the long term. So I'll leave it at that and allow some time for questions. Thank you.